Session at React Finland. Welcome back again. Hope you had a good time and good short break. We now have Andrei, Mark, and Naman. So this session would focus and show some demonstration on styling. How would you style your components? Some more knowledge sharing on CSS and JS. So let's quickly start with the introduction, each one of you. But mind you, you also have to share one fun fact about yourself while introducing. So let's start with Mark.
Hi, my name is Mark Dalgleish. I'm from Melbourne, Australia. Most well known for my work on CSS modules. Today I'm going to be talking about vanilla extract. And fun fact about myself, I once won a salsa dancing competition. There you go.
Nice. Okay, maybe Andrei, you want to go next?
Yes. Hi, my name is Andrei Pfeiffer. I live in Romania, Timișoara. I'm I'm organizer of. I'm very involved in the JavaScript community. I organize Team.js and Revo.js, which is a JavaScript conference here in Timișoara. And probably the reason why I don't maintain any CSS-in-JS library, so I need to get the disclaimer out. But probably the reason why I'm in this session is because I performed a thorough analysis of CSS-in-JS at the beginning of this year. So I could say that I'm a jack of all CSS-in-JS libraries, but master of none.
Nice. Thank you for the introduction. Naman, you want to go next?
Hi, I'm Naman. I work at Facebook and I developed the currently internal CSS-in-JS library there, which is what my talk will be about. And a fun fact about me would be that I very nearly became a filmmaker instead of an engineer. And today I got to use some of those skills for my talk.
That's wonderful. Okay, quickly to just, start up with one discussion and then we'll move on to some demonstration already. And please post all your questions if you have any questions for Mark, Andrei, or Naman. So, any application, maybe, React, or, even if you're managing Angular, we have CSS as sort of a big chunk, to manage. And I would like to ask, how do each one of you see managing CSS in your application? Maybe Mark, you want to go first?
I mean, it's kind of a big question. I'm not sure how to tackle it. I mean, for me, it's really about, well, we're building a design system, primarily meant to be accessed via the component APIs. And so we want to actually make it so that for the most part, you don't have to deal in CSS. Like we're aiming for CSS to be the exception. But that said, we want to make sure that when you do write CSS, we have good APIs for that. And internally, we're leveraging, we're targeting the web. So we want to try and target things like CSS variables as much as possible, but still focus on type safety and that sort of thing. So we're trying to get that balance of, ideally, you're not writing a lot of CSS, but when you do, you have the same level of, quality engineering you expect from any other layer of your stack.
Thank you for your answer. Naman, do you want to add something to it?
Yeah, it's similar. I do very similar things at Facebook. I'm working on the design systems and components. So something that's very interesting is we've spent a lot of time trying to figure out how to implement like particularly difficult layouts while keeping them server-side renderable. And it's actually quite surprising that I discovered that you don't really even need container queries, and you're able to, at least we were able to do everything we needed to do layout-wise with what CSS already provides presently. So that's kind of interesting, and our challenge is to basically abstract away all these CSS tricks in components so product developers don't have to deal with this esoteric CSS knowledge that nobody really should have to learn.
Andrei, do you want to add something?
Yes, I'd like to add something to reinforce what Mark already said. So I've been writing CSS for, I don't know, for a lot of years on how to write scalable CSS. So when CSS modules were introduced, and Mark basically is the co-creator of that, I thought that, okay, we got to a point where we can write good, let's say, decent, scalable CSS. And I think a couple of years ago, I started using TypeScript. So all the component code and the logic of the code was type safe, and I really started to understand what type safety and type checking actually means. And well, CSS and the styling part of the components didn't have any type safety at all. So that's when I started to analyze and to study. Okay, how can we get type safety in for the styling as well, for the CSS part of our code? And basically, this is this is where I'm at today. I really think that CSS-in-JS and CSS-in-TypeScript in TS basically is something that adds a really great benefit, because you get type safety for the styling part as well. Yeah, it's really great.
That's true. That's true. Thank you for all your answers. And moving forward, I would first like to invite Mark to demonstrate. And Mark, over to you. Thank you.
All right. So, hey, everyone. As you heard, my name is Mark Dalgleish, and what I'm going to be doing today is giving you a live demo of this relatively new library that I and others have been working on called Vanilla Extract. Now, as you can see here on the official website on the left here, Vanilla Extract is all about zero-runtime style sheets in TypeScript. The idea is really to try and bring these two, seemingly different worlds together: the world of static CSS and preprocessors, but the world of CSS-in-JS or CSS-in-TypeScript, and having the same language across the entirety of your app, including your styles, being able to share data, abstractions, and so on, but without incurring the runtime cost that you typically expect with CSS and JS. So rather than explain too much about how it works, what I want to do is show you what it looks like in practice. So here I have a basic app set up. I'm going to jump over to my Webpack app here, as you can see. Now, one thing I want to stress up front is we have integrations for different bundlers. We have integrations for ES Build, for Vite, for Snowpack, and more in the future, I'm sure. But today I'm just going to be showing you the Webpack version. So here what you can see is a basic React app. I've got my app component and it's rendering a header with some text inside. And if we jump over to our header, you can see it's just rendering some children in an H1 node. But let's say we want to start adding some styles to this. How do we do this in the world of Vanilla Extract? So what you can see here over on the side is that I've already created this header.css.ts file. Now, this is one of the unique things about Vanilla Extract, is that it feels more, ergonomically, it feels more like working with something like CSS modules and Sass. But the difference here, of course, is that we're using TypeScript as our preprocessor. And we get full control over what we're exporting from the file. So you can see here where I'm exporting this root class as it's returned from this style function call. So what I'm going to do is start adding some styles to it. We'll say I want the background to be pink, and you'll see as I'm typing, I'm getting auto completion and type safety from the CSS type library. I'm going to say that the foreground color here is blue, and I'm going to add some padding of, let's say, 16 pixels. Okay, so I've added some styles, and if you've worked with CSS modules, this is going to look familiar to you. I'm going to import star as styles from /header.css. Now it says header.css. It is the .ts file. There's no actual CSS file on disk. This is all happening through the Webpack plugin. So I've got my styles object here. I can add a class name to my div. And what you'll see here is that if I hit styles dot, my editor is already auto-completing this for me and telling me that there is a root class available. So if I add that, I hit save, you can see my UI has updated with my styles. Now, what's interesting, of course, is as you can see, it's all written in TypeScript. But if I view the page source, you'll see in this HTML, if I scroll across, I've got a main.css file, static CSS file on disk. And what's cool is that it's basically a one-for-one of what I've written. So you can see that I've got my root class coming through here. It's been prefixed automatically for me. Again, this is something that if you've worked with CSS modules, this is something you're used to. You can see I've got my debuggable prefix there, but there's a hash there at the end. So when I ship to production, it's just going to be those hashes coming through. And there are all those styles as I wrote them before. So there's zero runtime cost. Again, you can think of it just like using CSS modules in Sass, where all the code that's in that CSS.ts file runs at build time, and that's it. No runtime cost at all. Now, the next thing I guess that's really interesting about vanilla extract that's worth calling out is we're big on type safety and we're big on local scoping, and it's not just about class names. It's importantly, when it comes to things like design systems, you want to have that same level of DX around your themes. So let's say that these hard-coded values here are actually going to come from our theme palette, maybe a collection of CSS variables. What I can do is I can create a new file here that I'll call theme.css.ts, and I'm going to create some CSS variables. So export const vars equals, and I'm going to create a global theme, as we call it. Now, it's global in the sense that I'm attaching it to a selector. This is a common pattern if your app basically has a single theme. If you've got multiple themes, you can, there are versions of this that return a class name for that theme, so you can swap it in and out, but I'm going to keep it simple today. What's cool about this is that I can create a nested tree of variables. So here I'm going to have my colors, and let's say, just to keep it simple, I'm going to say I've got blue, pink, aqua, I can type aqua, try that again, and navy. There we go, we've got a few colors. And then we're going to add a space scale as well. So we'll add space of small as 8 pixels. Let's just, let's say medium, large. We'll go up to 16 and 32. Not a very realistic scale, but there we go. We've got our colors and our space. So if we jump back over to our header.css.ts file, I can start to replace these with CSS variables. But what's cool is that, as I've said, it's all type safe, and it's got that nested structure. So I can say vars.colors. And you see I'm getting auto completion here of all of my CSS variables. So here we've got our pink background list. To mix it up, let's use the aqua version, hit save. You'll see the background has changed. I'll change the foreground here. Same deal, we're going to say vars.colors.blue. And then the padding here, vars.space.medium. And of course, being type safe, if I've got a typo anywhere like that, if I've left a couple of letters off, I'm going to get my editor telling me that that's not a valid CSS variable. In the same way that you expect from something like CSS modules, where you've got your hash class names, we also have hashed variables. So if I jump into the style sheet again, we have another look. You can see there's our root selector for setting up all of our CSS variables. They've got debug names at the start there, as we've come to expect. These are only in development. Then you've got the hashes at the end. So in production, your styles are going to be referencing these hashed variables. Everything's going to be nice and lean. Another thing that's worth noting as well is that because this is all happening at build time, we're able to tie our localized classes and variable names to the file that it came from. So you have a single hash per file, and there's just a single counter at the end. Here you can see 0, 1, 2, 3. So that means that the compression is really, really good, especially the more styles you put in the singular file, which is very common in a design system, having a central theme file like this. Cool. Now, the next thing that's worth calling out here is that this is all still very basic, flat styling, what you would expect from CSS modules. But when you work in a component system, often what you want to be able to do is have namespaces of styles that map to props. Is a very common pattern. So for example, let's say that this header component, I want to be able to have a prop that can change the background color and can change the foreground color for me. So what I'm going to do is I'm going to introduce this new concept here of what we call style variants. So I'm going to create a background style collection of style variants. Now, style variants lets you pass an object here where collection of style variants. Now, style variants lets you pass an object here where you can create named sets of styles. The other thing that's useful here in terms of what we're doing is you can actually map over an object. So what I'm going to do is pass in our entire color palette, and I'm going to map over that. So in this case, it's mapping to the background. And what I can say is for every single CSS variable that I just passed in, map it to a style that sets the background. And I can do the same for the foreground. So if I change this one to color, we now have collections of styles for background and color. I'm going to delete these two here. So our colors are going to disappear. But that means we're now ready to reintroduce them at the component layer. So here we've got our interface for the component for the props. What I'm going to do is I'm going to add a new prop here called background. And what's cool is that because our style sheet is written in TypeScript, we also get access to the types that are coming from it. So I can say here that the background is actually key of type of styles.background. I can use the style variants object that I've exported as the source of truth for the types here of the props. So I can do the same thing for the color as well. And I can, of course, name these whatever I want, but I'm going to keep it fairly straightforward. And that means that these props now are going to be coming through here. So I've got our background prop and our color prop. I'm going to map these through to this class name. So of course, what I'm going to do before I go much further is make sure that I'm joining them with a space. So now we can make these dynamic. I can say that I want to apply the background, and it's going to use the background prop, looking up on that style variance object. And I'm going to do the same thing for the foreground color. Do that. Okay, so what's cool is that you'll see nothing's changed visually here in terms of the colors, but we are getting a type error now from our app component because the header component is not providing these required props. So if I start typing in here background, you'll see I'm getting auto completion of the available backgrounds. And again, tracing that through, that's because the type of the background is from the key of the type of our background styles inside of our header CSS file. So it means whatever I define here ends up being the prop interface of this component. So I'm going to set the background here to be pink again, like we had before, and still getting a type error because I need to set the foreground color, and we'll go with blue. And there we go. So what you can see is, again, what we're getting is type safe styles with zero runtime. I'm just generating plain CSS files. If I view page source here, again, all the way through, it's just a plain CSS file coming out the other end with no runtime cost. Now, if you're like me and you're working on a design system, this sort of low-level atomic mapping code effectively, I have a single class for each background color. I have a single class for each foreground color. This concept is not really coupled to the idea of this header component. This is a generic app-wide concept that I want to be able to reuse classes. And if you've ever worked with something like Tailwind, then you're definitely used to this idea of being able to reuse these classes throughout your app and being very utility first. So this is something that we use in our own work with Vanilla Extract at SIG, where I work in Australia. And to make this easier, what we have is actually a first class official package that's part of the Vanilla Extract monorepo called Sprinkles. Now, you can think of Sprinkles as basically like the Tailwind of Vanilla Extract. But the difference here is that we're leaning heavily into TypeScript and having type safety and type safe functional interfaces for our classes, rather than manually building up these strings that you typically get with utility class frameworks. So in order to make this work, what we're going to do is jump down here, and we've got a bit of a starting kit here that I can grab. I'm going to highlight all this code, and I'm going to drop it in my theme file. Place that import to the top. So we've still got our vars. We're going to use our vars as the source of truth. I'm going to delete the space here that's come with our little template, and we've got colors here as well. I'm going to delete those. So already you can see we're getting, as always, we're getting type errors. That's going to make things a bit easier for us to fix it up. So rather than it just being space, I want it to be vars.space. And then down here, we want it to be vars.color. So we're using our CSS variables as a source of truth for what these the values of these atomic classes should be. Now, what I'm going to do to keep it lean, I'm just going to delete the things we're not going to use today. I'm just going to keep it simple. But we have, what's neat is we've got shorthands here as well. So we've got padding, padding X, and padding Y that just map to these low-level top, bottom, left, right. We also have color styles here as well. The reason for the separation is we have different conditions, which I'll get into shortly, but it means that we can very easily, in a type-safe way, customize the styles that we want across different screen sizes or different color modes. And this is all configurable. Your conditions can be based on media queries or selectors or whatever you want. Okay, and then at the bottom here, what you'll see is we're exporting this atoms function. And that's what gives us the type-safe interface to these atomic classes that we've configured. Now, this function can be used inside of your CSS-TS file. So I could replace these with atoms calls if I wanted to. But what I'm actually going to do is show that the real power of this approach is that this atoms function can be used at runtime. What I'm going to do to keep things simple, I'm going to roll back to a component that doesn't accept any props. So we'll just delete these background and foreground colors. Jump in here. These are now gone. What I'm going to do instead of having this CSS file is I'm just going to use my low-level atoms function directly. So here we're going to say atoms, and that's coming in from my theme file. I've got this atoms function. I'm going to say that I want the padding to be large, medium, small. You can see here. So these, again, it's all type safe. It's coming from our sprinkles configuration that we just looked at before. I'm going to make that medium. What I'm going to do here now is set the background to be pink, as we saw before. And I'm going to set the foreground color to be blue. Again, same styles as we've had before. So we're basically back where we started. But what's interesting is if I open up the dev tools and I inspect this element, what you'll see is that we've got atomic classes for everything. We've got background, foreground, padding, right, left, bottom, top. If I view the resulting CSS file that's being generated, you'll see we've got all of our variables up top. We've got all these atomic reusable classes defined for different breakpoints. We've got our tablet styles, our desktop styles here, and then at the bottom here we've got our dark mode colors as well for color and for background classes. So, because this is all statically built into a CSS file with a function that just maps to those at runtime, it means there's actually effectively zero runtime cost apart from the lookup of mapping to these pre-existing classes. But what's neat about what we've done here is that we can start to do much more advanced things than just mapping these simple values. Because we set up our conditions, we have conditions for padding and colors that behave slightly differently. What we're going to do here is say that for padding, we want on mobile to be small. Then on tablet, we want it to be medium. And then on desktop, we want it to be large. And one thing I want to stress is that this naming convention is just something I've come up with. You can name these whatever you want. You can map it to whatever media query you want and so on. So that means now that I've made that padding responsive, you can see as I resize my window, the padding is changing. And because this is in my runtime layer, it means I can actually map these values through to props, and I can make this as configurable at runtime as I want. The other thing that I can do here as well, as you would have seen before, is that I can start to target light mode and dark mode. So I'm going to say in light mode, I want it to be pink, but then in dark mode, I want it to be, we'll flip it around, we'll say blue. Now my OS is set to dark mode, so you'll see the color actually just flip for me. So what I'm going to do is do the same thing here for the foreground, but we'll go with the opposite. We'll say that in light mode, the foreground is blue, and then in dark mode, it is pink. So if I open up my dev tools and I bring up this panel here, if I scroll down, you can see here I can emulate prefers color scheme. I can switch between light and dark mode. And that's just alternating between, because I've applied classes for both of these states, they're swapping in and out for me. And again, if you look at the resulting markup in the page, you're seeing that I've got a lot more classes now. But the good thing is that this is mainly for development again. So you've got all these prefixes here of theme background, theme color, theme padding, and so on. In production, this will just be a wall of hashes and end up being a lot shorter than what you're seeing here. And again, if we view source, even though it's all dynamic between light mode and dark mode, what we've done is we've sort of invested in this lean set of classes up front, and then at runtime, beyond that, there's no real cost for that. And this is what you're seeing here is really the basis for all of the work that we've been doing at Seek in our design system. And in practice, what we found is that we can build this really lean, reusable, highly compressible set of classes, and then move a lot of the logic for swapping in and out of these classes to the runtime, where the ergonomics start to feel a lot like your traditional runtime CSS-in-JS solutions, but without the performance costs, because we're just referencing these pre-built atomic classes. So hopefully you find that interesting in the sense that you can see that there's room for some of these approaches that try to bridge the worlds between static CSS and pre-processes, and knowing that there's zero runtime cost in all of that work, but then having the ergonomics of a runtime CSS-in-JS solutions and being able to integrate your styles into your component APIs and so on. So that's it. If you're interested in trying it for yourself, I do encourage you to check it out, vanilla-extract.style, and try it out and let me know what you think. I'd love to hear how it goes. And that's it for me. Thank you so much for listening.
Thank you so much. That was a lovely talk. And I mean, I'm going to use myself now Vanilla Extract for my side projects. So it was really amazing. We have a quick question from Oli. So he says that to get the most out of Vanilla Extract, would all the styles buy in Vanilla Extract? Would there ever be a good use case to have something inline out of Vanilla Extract?
Yeah, so I think the way I think about this is it's really no different to the way you think about working with something like CSS modules in Sass in terms of the trade-offs, because if you want to do something at runtime and you're using static CSS, you may have to reach for an inline style in that sort of a scenario. But I guess what's interesting now that we have CSS variables is that you can make your CSS variables dynamic at runtime as well. So Vanilla Extract, I didn't touch on it today, but Vanilla Extract has a special package, /dynamic is the name of the package in the namespace. And what that lets you do is have a sort of a first-class type-safe API for changing the value of variables at runtime. And so that's another way that you can sort of have the best of both worlds, where you can write the static styles, put dynamic placeholders in there in the form of CSS variables, and then swap those out at runtime as well. So that gives you a little bit more control to do things like that you typically can't do with inline styles. So for example, you could have variables for different breakpoints and have them applied as inline styles. That inline styles typically can't do responsive styling. So we have a lot more tools available to us to do that now than we used to.
We have Samoli who says that it looks amazing. We'll definitely try it out. So good on that. Just a quick question on performance-wise compared to other CSS in JS. Do you want to say something about that?
Yeah, I mean, so that's really, where this work is coming from is from the perspective of, obviously with my involvement in CSS modules, we invested in that ecosystem really, really early. And the entirety of our design system, lineage going back many, many years at this point was all built on this assumption that there's zero runtime cost. And we scaled that up through a large company, right? And so the challenge for us was that we wanted to move more and more towards the benefits of CSS in JS or CSS in TypeScript particularly. But we were worried about pushing out a runtime to these consumers that were already used to the performance characteristics of static CSS. And so, I'm not against the idea of runtime CSS in JS per se, but it's more that, in that sort of environment, it felt like, we felt like we wanted to do the right thing and see, like, do we really need to introduce a runtime, or is there a way that we can kind of have the best of both worlds? And so what you're looking at really is, what does it look like to maintain that same performance profile of effectively zero runtime? It's just static CSS files. And the only runtime really is just the typical lookup that you would have to do anyway with any static CSS solution. And beyond that, there is zero runtime cost at all. So it's going quite extreme in terms of the trade-offs and trying to see how far we can push it. Some of the trade-offs there, of course, as you've seen, is we've got a separate file that you have to worry about, and that static export boundary. But we actually find that in practice, that actually helps people understand, where is that boundary between the code that runs at build time, the code that runs at runtime, and it's clear that there's anything that's in that CSS-TS file can be as expensive as you want. It's not going to hit your users.
So I'll just ask a question here too. So are you actually running all?
Yeah, so that's one of the reasons we went for that sort of approach, is it makes it really easy to signal to the bundler that this is a point at which we actually need to spin up a child compiler, compile that into its own separate context that we eval, and all CSS that gets generated gets output into these virtual CSS files, and all the exports, those are the things that are left in the file. So the fact that there's that boundary, that's such a clear boundary as well, has made it really easy for us to port to other bundlers. So like getting into ES Build, for example, was really trivial because we didn't have to do any AST work at all. It's literally just, if we see that extension, we know, spin that one up, and it's in a separate process.
Cool. So maybe this question is for all of you. Where do you see CSS and TS heading in next few years? It seems like there has been a recent boom in zero-runtime CSS. Maybe. Mark, do you want to take it?
Yeah, I mean, this is a tricky one because I think, so with CSS modules, I think it was really obvious from the beginning that it had the potential to be really big because it looked and felt like regular CSS files, and it integrated seamlessly with existing CSS tooling. Like you could plug Sass into it and auto prefixer and post CSS, whatever. Like it just felt like it was part of the CSS ecosystem. You could hand it to an ostensibly, CSS focused developer, and they'd feel right at home. Whereas what we're looking at here with CSS and TS, it feels like it's got a bit more of a hurdle to get over to get more of that mainstream adoption outside of maybe, people at a conference like this are perfectly happy with the idea of CSS and TS. I think, your more traditional CSS developer is going to have a harder time coming to terms with the idea that they're completely flipping out the language to something like TypeScript. I'd like to think that with the right approach of presenting it to them and maybe writing specific articles or creating specific videos for that audience, knowing that they might be more skeptical, I think that the benefits of type safety are what pushes it above and beyond JavaScript as a sales pitch. Because I think if you looked at what we were doing before, it was, for them, it's much easier to write it off and say, well, you're just using JavaScript. Like, I don't see that as such an advantage, to that audience. But if you say, look at what I'm doing with CSS variables here, where I'm actually getting like auto completion, type safety. I know for a fact that all these variables I'm referencing do exist. And if someone deletes this variable, my app will get a type error. Like, you're starting to see things that even a dyed-in-the-wool like traditional CSS developer is going to have a hard time saying that's a bad idea. I think they're going to start to say, okay, there's something interesting here. It might take a bit longer. So, you're talking about the next few years. I think that's probably maybe the sort of time frame you're looking at. I mean, even CSS modules took a while to become the sort of safe, boring choice. I think, there's room for some of these CSS and TypeScript solutions to get to the same place, but it might be more of an uphill battle, I think.
Okay, there's one more question for you, Mark. I think you mentioned the theming part a bit, but is it possible to create nested themes easily, toggle between them?
Yeah, so in order to keep the demo simple today, I used create global theme, but we also have just a create theme API. And what that returns to you is a tuple of the theme class itself and the vars. So then it's up to you to then put that class somewhere in your document. That obviously means there's a little bit more wiring up to do on your part, which is why I didn't do it today. But in our system, that's what we do. We have a system with multiple themes that you can swap in and out. The other thing that's really cool as well, this is more advanced usage of vanilla extract, but we also give you the ability to create theme contracts in isolation. Why that's useful is it means you can bundle split your themes, and you can say that you can like your app code imports the theme contract and has access to the var names, but it's up to you at runtime to decide, well, which implementation of that theme contract am I going to use? So from vanilla extract's perspective, we support every theming use case from, the one global app theme for your app all the way through to like lots of separate themes that are bundle split and optimized that way. So we handle whatever you need to do there.
Thank you. We have another question. Will vanilla extract support CSS collocation, aka placing styles in the same component?
Yeah, this is like the number one question we get with this library, because it's definitely one of the biggest trade-offs we've made. I would say we've debated this one quite a bit earlier on, and I've often been the one trying to challenge ourselves to be like, is this something we really need? People don't like it. I think ultimately what it comes back to though is at some point there has to be a boundary between the code that's going to run at build time, the code that's going to run at runtime. The challenge with putting it in the same file is it's very easy for you to write code that just does not make sense, because you're trying to do things that, you're trying to reference things that actually don't exist at runtime. And so then you have to introduce things like lint rules and, to guard against people doing things that don't make sense and so on. Whereas if you put it in the separate file, effectively, in my mind, the reason why it feels right in practice is it's going with the grain of JavaScript, in the sense that the export boundary of a module is static. Like you're actually forced to think about it in that sense. Like I can do all this work in my CSS-TS file, but I have to sort of up front decide these are the things I'm exporting from my file. And so it means that there's no longer this sort of confusion of like my React code's trying to reference variables that I defined in my styling code that actually should be gone at runtime. And it just makes it much easier to reason about. It also helps with this is not the reason we do it, but it also pays off in other ways, in that it means there's a lot less work for us to do to figure out where that boundary is, and integration with different bundlers and different environments is a lot more straightforward for us as well. But I would say the main reason is about making it feel natural in the language that that boundary is inherently static.
Thank you for that. What are some of the interesting projects that you're following outside of your own? Maybe to all of you. This question is like to all of you.
Well, I'm interested to see Stylex. Very interested.
And Naman, maybe you can go.
I've actually been looking at vanilla extract, and I learned way more today because I wasn't completely familiar with sprinkles. And just a little extra add-on to the last question, I think with Stylex, we've kind of made the other choice where we do co-locate styles in the same file. But other than that, I feel like we're trying to follow many of the same things. It's typed, it's static, and all of that. So I think it's very interesting because other than that one decision, we're both chasing exactly the same goals.
Andrei, do you want to add something?
Yes, I tend to remain unbiased towards any CSS-in-JS library because I like to try all of them and understand each of them and understand where they basically fit in a particular project. I've used Treat, which is the grandfather, I don't know how to call it, the grandfather of a vanilla extract. And we are planning to switch also to migrate to vanilla extract. So that's one library that yeah, that really makes sense to me, and I follow it. Another one would be I would say Goober. Goober is a library that has a runtime overhead. So it's from my perspective, it better suits like highly dynamic applications on single page applications. And I will debate on this during my talk, and we'll debate the performance applications. And I will debate on this during my talk, and we'll debate the performance of both these approaches as well. But yeah, Goober, because it's probably the most lightweight and also like really rich in features. So yeah, that's one library that I really I'm impressed. I'm really impressed.
Thank you. Thank you for all the answers that you shared. Moving on to our next presentation, I would like to invite Naman Goel. So the stage is yours, Naman. Over to you.
I have a pre-recorded video. Stylexjs. My name is Naman Goyal, and I'm a UI engineer at Facebook. So, what is Stylexjs? Stylex is a CSS-in-JS library that is fast, familiar, and flexible. Let's look into what that means. Stylex is fast as it statically generates a CSS file at compile time. So Stylex is really written in JS, but not executed in JS. It detects and removes unused styles, uses atomic styles for maximum reusability, and easily generates critical styles. Stylex also uses zero-cost abstractions wherever possible, so you only pay for what you actually use. Next, Stylex is familiar because it has a simple API inspired by React Native that lets you declare groups of styles and objects just like you would while declaring class names. You can continue to nest pseudo-selectors and media queries within those objects just like you would in your favorite CSS preprocessor. And you can pass those style objects directly to the class name attribute like you would set class names. Stylex also lets you define fallback styles for progressive enhancement, and it avoids using any special syntax when a simple string might suffice for things like CSS variables, calc functions, etc. Finally, Stylex is also more flexible than almost any other CSS-in-JS library out there because it gives you features like an intuitive API for declaring conditional styles. You can simply use ternary statements and other JavaScript expressions. You don't have to learn any new special syntax. Stylex also lets you pass styles between components and compose them in a very predictable way. Further, styles are completely typed and can be constrained with prop types. Stylex has managed to remove all specificity wars altogether. So even if you split up your generated CSS file, you can load it in whatever order you want and things will work consistently. Finally, Stylex gives you a way to generate CSS variables automatically when you need to create some dynamic styles, and it integrates with build tools like Webpack, Rollup, and you can roll your own integrations in the future. So, what does Stylex look like? This is a simple example. If you're familiar with React Native, this might look quite similar. Even if you're not, these style objects should look fairly similar to defining class names. As you may notice, we use the words start and end automatically. If you want to add pseudo selectors or media queries, it's quite simple as well. But let's stick to something simple for now. This simple example generates the following HTML and CSS. There is a simple div on the left with a list of class names, and the generated CSS on the right with one class name for each style. We'll dig more into atomic styles later, so for now, let's go back to the code that you would write. Once you've written this code, Stylex comes into play. At compile time, the stylex.create call is removed, and the values are replaced by the associated class names. The rest is left as is. This is how you should think about Stylex in your mind while using it. The Stylex function works like an object.assign, but it's able to merge objects deeply. But I said that Stylex likes to create zero-cost abstractions whenever possible. And while JavaScript objects are cheap to create and merge, it's not a completely free process. And so, in an example like this, when Stylex can see all of the styles defined within the same file, it can optimize further and remove the objects altogether and leave you with something like this. Stylex is smart enough to detect that some of these styles were applied conditionally and create the strings accordingly. Next, let's look at how Stylex gives you predictable style resolution. When you're writing regular CSS, the order of the class names doesn't matter at all. In this particular case, the class name red comes first and the class name blue comes second. But even if I reverse that order, the box on the right remains blue. This is because the class name blue comes later in the style sheet. In order to make the div red, we actually need to change the order of the class names itself. This is not completely practical in a production app because you can't guarantee that your CSS will load in any specific order, especially when you want to bundle split it. Stylex solves this problem completely and gives you a simple rule of thumb. The last style always wins. In this particular case, styles.blue comes last, so the box is blue. If styles.red came last, the box would be red. The order of the styles doesn't matter, only the order in which it's applied. This even extends to style shorthands. Consider this example when you're using margin and margin vertical. Again, notice that you have the ability to write margin vertical, which defines margin at the top and bottom, just like React Native. In an example like this, it might be somewhat trickier to decide what the final style should be. If styles.active comes last, we would probably expect the margin of 8 on the sides and margin of 16 on the top and bottom. But what if I was to change the order? What would happen now? In other cases, this might be a little confusing to decide, but in Stylex, we can follow the simple rule of thumb. The last style always wins. And so in this case, we can say with certainty that the margin should be 8 on all sides. Stylex does this by automatically expanding all shorthand properties at compile time, which means that even though you wrote margin and margin vertical while coding, at compile time this gets expanded into this. This ability to compose styles consistently lets us compose styles across components. So say you're defining a component, you can now just accept a prop that is a style object. In this particular case, my component takes a prop called xStyle, and you can pass it with any style object defined elsewhere. You can even define multiple style objects, and Stylex will automatically merge them. You can even define styles conditionally. The xStyle prop behaves exactly like the Stylex function. But remember, I also said that these styles are all typed, which means that if you're using TypeScript or Flow, you can provide prop types for the xstyle prop. The most simple case would be the xstyle type. Xstyle stands for external style. This gives you the ability to pass any arbitrary object of styles. But you can constrain this a little further and define just the keys that are allowed to be passed into this component. So in this example, my component takes styles for color and margin, but nothing else. We can take this a step even further and even define the values that are allowed for those keys. That was a quick tour of what Stylex looks like. Now let's look at some of the design decisions behind Stylex. First, atomic styles. Regular styles look something like this. You define a class name and you define a whole bunch of properties for it. But atomic styles flips that on his head and gives you one class name for each property. At first, this may seem wasteful, but in production, this ends up saving you a whole bunch of bytes. When using classical CSS, the number of CSS bytes grows linearly with the number of components. When you're building large web apps, such as Facebook, the number of CSS bytes can go into megabytes or even tens of megabytes. But when you use atomic styles, after a certain number of components, the number of CSS bytes starts to plateau. This gives us a whole bunch of performance benefits. Atomic styles makes it so that the CSS file is small enough that we can just load the entire CSS file up front without worrying about performance. This also eliminates the performance penalty of loading additional CSS at runtime. And the browser has a much easier time resolving styles that should be applied as your HTML changes. Other than the performance benefits, there are some features that atomic styles give us as well. Since every style has its own class name, we can target by style. Consider sticky position. Sticky position is a very useful CSS property, but it breaks completely if it's embedded within an overflow hidden element. Now, by targeting by style, we can look for anything that might have overflow hidden set on it and then handle that case accordingly. In this example, I'm looking for any parent that has overflow hidden on it, and if this element is a descendant of that element, we can apply some different styles. Next, consider a value like current background color. CSS already gives us current color, which gives us the current value set for text color, but it doesn't give us anything for current background color. Since we use atomic styles, we can just polyfill this feature in. Every time a class name is generated for a background color, we can automatically insert a CSS variable that sets the variable to that same color. CSS variable that sets the variable to that same color. Next, let's look into the tooling for Stylex. Stylex's tooling builds on top of three pillars. Firstly, there is a Babel transform that compiles away some function calls, such as stylex.create, and it helps you extract a static CSS file. Next, there is an ESLint plugin that validates your styles and detects unused styles. And third, static types, if you choose to use them, validate that your style objects that you pass as props are correct, and that when you compose styles, you're composing style objects created using stylex.create and not other objects. Finally, let's look at the developer experience. Stylex tries to give you the best developer experience possible, and so Stylex will work even if there is no tooling set up. When you're ready, setting up a build process will help you be production ready. Stylex also supports fast refresh out of the box. So you may be wondering when you can use it. Stylex was initially made for the new Facebook.com. It has since been adopted by Workplace and WhatsApp, and Instagram is currently in the process of adopting it. But Stylex is not quite ready for prime time. We're working on it hard, and we expect to open source a beta this year. We can't wait to get it into your hands. To recap, Stylex gives you a simple React Native-like API. It is fast, familiar, and flexible. It builds on top of Babel, ESLint, and static types. It uses atomic styles to give you performance and unique features, and it should be open source this year, hopefully. Thank you.
Thank you. That was a wonderful talk, Naman. Thank you so much. Okay, we have a few questions now. So we have one question from Andrei. How does Stylex guarantee that the last applied style always wins in two different components which apply styles in different ways?
So can I ask for a clarification on this question since you're right here? When you say two different components, do you mean when styles are being passed in as props, or do you mean two separate components that have nothing to do with each other?
Let's say you have two different components, like your example with the red and blue classes. So
right.
One component applies them in one order, and the other one in reversed order.
Correct.
The style definition in your style sheet will be like static.
The same.
Will be the same. Probably the first one that is encountered. But the other component will like to display them in reversed order, but that won't apply out of the box. So I don't know if that's something that you handle or Stylex handles.
So Stylex does handle that, and it's I guess I should have spent more time on that. But at the very beginning, once Stylex.create has been extracted out, and you basically have these objects, essentially what you're left with at runtime, at least for just to think about, there can be more optimizations, are these objects which have keys like color on the left and class names on the right. And when you apply those objects onto a div, you're merging these objects. So at any time, you will only ever have one class name that defines a certain property. So it's impossible for there to be two colors defined in two separate class names, both being applied to the same div at all. You'll only get either the blue class name or the red class name. You'll never get both on the actual div, because when you merge the two objects, the keys will clash and the last one will win. It's exactly like object.assign.
Okay.
So the idea was to basically give you an experience that is as close to inline styles as possible without the slowness of inline styles.
Cool. Thank you for that. Let's see if we have some more questions. Okay.
I have another question in case
sure.
There aren't any. So I guess that you mentioned something about server-side rendering, and Stylex, I guess, supports server-side rendering. And I'm curious if you did some measurements regarding the overhead. I'm talking about file size now. You say the CSS file is vastly reduced, but I don't know if you measured the increase in probably the increase in HTML in the server-side render content increase. Does that at the end? I mean, did you get a benefit at the end, like an overall decrease in file size?
So I guess Facebook's a kind of bad example for this, because before Stylex, we were using something that kind of looks like a very plain, dumb version of CSS modules, and we don't use Webpack or anything like that internally. So before Stylex, the total CSS that Facebook.com had was in like tens of megabytes. Not that it would all load, but if you kept on clicking on more and more pages, it would keep loading additional CSS. And it was possible to get into like more than 10 megs of CSSs on the page. With Stylex, we are under 200 kilobytes like before gzip, which is pretty good. And as of right now, we just load the entire CSS file up front, which is like, if we need to, we could optimize it further, but in practice, it's been totally fine because you paid maybe a small amount of extra penalty up front to just load all the CSS, but then you never have to worry about it again. And the HTML itself is bigger, but only when it's not gzipped. Because there's so many repeated class names all over the place, it actually gzips extremely well. So the increase in HTML size is actually quite small. And one thing that I kind of touched on is with something like Facebook, where there are pages where there's like 5 things going on at the same time. There's a header, there's a chat window, and 3 columns. When you have a complicated page like that with a lot of HTML, loading additional CSS was actually a performance bottleneck for us. So none of the HTML changed, maybe like one tiny little dialog opened and it brought in an additional CSS file. And that was a performance bottleneck because as soon as you bring in new CSS on the page, the browser has to recheck everything on the page to make sure that the same CSS still resolves for each class name. It needs to make sure that nothing changed because of new CSS on the page. And the fact that we don't have to load new CSS all the time completely removes that problem.
Got it. Thank you.
Naman, I have a quick question for you. So how are the theming support and how do you handle like the global CSS with Stylex?
So that's something that I was trying to learn from Mark on. But like we had something that was a little more similar to that. And we needed like kind of a complex solution because we were still supporting IE 11, which doesn't have CSS variables, but we've recently dropped IE 11, so we're investigating if we can do something better. As of right now, we don't do anything, which basically just means that we define CSS variables in a plain CSS file before the Stylex generated file, and then we just use those variables as strings as is. So theming is like global theming is supported, but like Stylex doesn't do anything special to help you with it. You just do what you would do with vanilla CSS.
Thank you for that, Naman. Mark, I would like to know your views on Stylex.
Yeah, I think it's really interesting to see like how many different trade-offs there are to make if you're trying to tackle this problem. What I think is really interesting about Stylex is it's trying to be, the way I look at it is it's really going for the least amount of trade-off from the developer experience of trying to make it feel as if you're not doing anything static, built time. It makes it like you look at the code and the ergonomics of it, it feels like Naman said, it feels like inline styles. And obviously that's a harder problem to solve then. So there's trade-offs then around, what the tooling has to do. So a good example of one big benefit of that Stylex has over vanilla is that with vanilla, you're very much still in that world of like having to worry about specificity. And if we swap the order of class names, it doesn't do anything, right? And so there are ways to solve that. Like what we were doing with sprinkles is a good example of where we sort of build abstractions on top that kind of force you into a system where you can't apply the same like competing styles. But it's really interesting, I think, like seeing how little they're compromising on the developer experience.
Andrei, do you want to add something?
I'm just waiting for the open source so I can take a broadcast.
So to comment on Mark's comment, we had actually a very different experience internally with engineers, where engineers were more willing to like forego features entirely than change the developer experience. So when Stylex was new, it didn't do any composition. It didn't do almost anything. Like all the styles had to be local to the file. So like the best case scenario for performance was the only possible case. And engineers would rather have that than an API that was more complex. So we had to find ways to add features without like making anything harder for anyone.
Naman, last question for you. What do you think about vanilla extract?
No, I think vanilla extract is like really fascinating. I saw it a while ago and I was like, this is interesting, but I don't fully get it. And then I've heard Mark talk like twice now, and every time I hear him talk, like vanilla extract makes complete sense, like before this talk even. And then I wasn't completely sure how sprinkles worked, and that makes much more sense now. And I got to ask him the question of how it works, and that is what like made it click for me, because I was like, okay, I get what it does, but I don't see how. And it was like, now it makes sense. The curtain has been lifted, and I find it really fascinating because, as I said, like I feel like we're chasing very similar goals from slightly different directions, and I'll definitely be trying to learn from vanilla extract. I'm already thinking about how to do theming in a similar way, but with the Stylex limitations and design constraints.
Thank you. Thank you. So I think we will move on to our next demo, and please post your questions if you have any. We can also take it later. So next we have Andrei, and over to you, Andrei.
Yeah, thank you, Manjula. Yes, my name is Andrei Pfeiffer. As I mentioned, I live in Timișoara, which is in the west part of Romania. You can find me on andreipfeiffer.dev. This is my blog that I'm currently running. I'm also very involved in the JavaScript community. I organize Team.js, which is the local JavaScript meetup here in Timișoara, and we also organize Revo.js, which is an annual JavaScript conference, not for profit, which hopefully we'll be able to organize next year again. And you can find me on Twitter, my handle being Pfeiffer_Andrei. Pfeiffer is spelled exactly like Michelle Pfeiffer. So as I mentioned, today I would like to talk to you about a thorough analysis of CSS-in-JS that I have performed at the beginning of this year. What this analysis is basically more than a 2-month study of most CSS-in-JS libraries out there, which of course I cannot cover entirely in this 15-minute talk. So I will focus on only one small aspect of it. But you can check out the entire study at my GitHub page, github.com/andreipfeiffer/css-in-JS. The reason why I made this analysis, I wanted to explore a type safe to write CSS. As I mentioned, I used TypeScript in most of my application code, so to write the business logic and to write components. So I got all the benefits of type safety for the rest of the code, but the CSS part and the styling part are not natively type safe. So this is why I explored all these CSS-in-JS solutions to find a way to write type safe CSS. We were particularly looking for server-side rendering, libraries that support server-side rendering, and being able to easily integrate with Next.js. And of course, we were looking for full TypeScript support. In this regard, we looked over most CSS-in-JS libraries out there. To be honest, there are more than 50 of them, we only looked over about 20, and we eliminated part of those because they didn't meet our criteria. So we only focused on about 11 libraries. Now, all of these libraries have so many things in common, which are documented on the GitHub page that I mentioned earlier. But today, as I said, I would like to focus on one particular aspect that also my Mark and Naman mentioned previously. I would like to focus on how these libraries output their styles to the browser. And I found that there are two different, let's say, mutually exclusive methods to make this possible. The first method is, I call it Runtime Stylesheets, and the second one is static CSS Extraction. And both Stylex and Vanilla Extract use this, the second method, static CSS Extraction, or the zero-cost runtime, the so-called zero-cost runtime. So let's see how these two work from a very high-level point of view. So using Runtime Stylesheets, it's important to mention that most CSS-in-JS libraries implement this method. And basically, when we define all the styles, they are within the JavaScript files, along with the components that we defined. So when we build our application using whatever bundler we have, we get a JavaScript bundle, a huge JavaScript bundle that contains the components, the application logic, but also the styles definitions as well. And of course, we need an additional code, let's call it the runtime or the library runtime, that has to be shipped to the browser, which basically knows how to read the styles and to inject them into the DOM so the browser can display the styles, because the DOM doesn't know how to read styles out of a JavaScript file. There are many different ways to perform this injection. I won't go into the details, but we can discuss this further during the Q&A. So let's move to the other method, the static CSS extraction. Well, as Mark and Naman mentioned, basically at build time, the library knows how to extract all those styles definitions from the JavaScript or TypeScript files and generate a static CSS file, an actual CSS file that you can include like any other style sheet into our document. And the JavaScript bundle will only contain the components and the application logic without any styles definition, because they are already extracted as a separate file, which is pretty interesting. Now, there are two different things to talk about when we think about performance. The first one is the size, right? The size output. So let's look at a typical client-side rendering with runtime style sheets. So when we are doing client-side rendering, the HTML file that is shipped to the browser is usually pretty small. It's basically an empty container that will render everything on the client. We will get a huge JavaScript bundle, and part of this JavaScript bundle will be represented by the styles definitions, and as mentioned earlier. And of course, we need to ship that runtime to inject the styles into the DOM at runtime. When we are doing server-side rendering, there is something different happening. So the HTML file on one hand would be much larger because we are shipping all the rendered content that is already rendered on the server. And we also need to ship the so-called critical CSS, which is the CSS, the styles that are required to display the initial HTML page that is rendered on the server. All the JavaScript libraries that implement runtime style sheets will implement, also support this critical CSS extraction and injection into the generated HTML file that is rendered on the server. So this is you get this out of the box. But it's important to notice that this critical CSS will be shipped twice to the browser. Once in the HTML file, and second in the styles definitions that is bundled with the JavaScript bundle. So it's it's a good thing to keep in mind, this limitation. Now, when we are looking at static CSS extraction, the HTML file is the rendered HTML file, let's say this file, that is pretty much the same size as the style definitions. There are slight variations, but let's consider for simplicity, let's consider that they are the same size. And the JavaScript bundle will be shipped as well. So we can clearly see that when referring to file size, static CSS extraction looks more appealing because we are shipping less bytes to the browser. And also keep in mind that CSS files and JavaScript files are very easy to cache by the browser, while HTML is not that trivial to cache. There are methods to do this, especially when we are talking about static CSS, static files, right? Static HTML. But when we are doing server-side rendering and dynamically rendering on the server or on the client, it's not trivial to cache. Now, as I said, from this point of view, like this static CSS extraction with zero runtime look really fantastic from this point of view. From the if we think about size alone, but let's look at another metric that we can think about. Let's look at time. So how long does it take to load these two different pages that use different libraries with different methods to output the styles? So this is an HTTP request, like a very basic representation of it, and it has two primary parts. The first one is the time to first byte, which is the time that it takes for the browser to make the request to the server to respond or to basically compute the response, and then for the browser to receive the first byte of information from the server. What influences time to first byte is latency, networking conditions, how the busy is the server, how long it takes to process the request, all that stuff. And the second part is the downloading part. The time it takes for the browser to basically download the entire file. Of course, smaller files will have a smaller download part, and larger files will have a bigger download segment. And also, it's very important to keep in mind that on a fast Wi-Fi connection, the download part is going to be very small compared to the time to first byte part. Right, you would see this in Chrome DevTools or whatever the debugging console you are using. But on a slow mobile, for instance, the time to first byte will definitely be slightly longer, but the download part will be much longer in proportion with the time to first byte. So it's worth keeping these two scenarios in mind. And finally let's look at how a typical waterfall chart looks like when loading a page. So on top we have the runtime style sheets, on the bottom we have the static CSS extraction, and we are considering an empty cache. So nothing is cached at the moment, so everything needs to be downloaded. So we are downloading the HTML, which contains the critical CSS if we are performing server-side rendering. It takes some time to download that file, and after the file is parsed, considering that we are probably including the JavaScript files at the end of our document, those can begin to be downloaded and parsed as well. We can prefetch them, of course, and we can save some time, and we can optimize this process if we need to. But it's important to know that the first paint or the browser cannot start painting anything on the screen until it downloads the entire HTML file, and it parses and downloads all the resources that are specified in the head part of our document. If we don't specify anything in the head part, it can start painting right away, right? Now let's look at static CSS extraction. So with static CSS extraction, the HTML file is going to be a bit smaller, of course, but the time to first byte basically is pretty much the same if the server and the networking conditions are the same. And a static CSS file is usually included in the head part of the document. So, as I mentioned, the browser cannot start to paint anything unless before it downloads and parses all the resources that are included in the head. So in this situation, the first paint will occur definitely later than in the case of runtime Stylesheets, because we need to make another request to the server to fetch the styles. Now, as Naman mentioned earlier, we can embed these CSS styles or roll the CSS file into the HTML file. We'll download more content, but we can save this extra request and optimize this better. When you have a full cache, so on a second visit on or subsequent visits on our page, all the CSS files and JavaScript files will basically be cached by the browser, and the first paint will basically occur pretty much the same, but at the same time. But the first visit is definitely gonna differ a lot between these two different approaches. Now, it's worth mentioning that this is sample data. This is an oversimplified example. It might not apply to your use case. Of course, we need to include many other resources in the head or in the body of our document. So it depends on very many aspects to draw a definite conclusion which one is actually faster. Of course, this doesn't cover the time to interaction or other metrics that could be important for your use cases. But as a general conclusion, at least my own conclusion, looking at this mental model that I have created for these two methods, is that I look at runtime style sheets because I see them more suitable for client-side rendering and single-page applications when we are not required to ship that critical CSS along with the HTML file. And of course, we need fast first paint metrics in this situation, because we need to paint as fast as possible something to the user, because we need to fetch additional resources while after the initial HTML file gets to the browser. With static CSS extraction, on the other hand, you get less bytes transferred, and we also get better caching. So from my point of view, it looks more suitable for server-side rendering or static pages. So I think I look at them as two different methods that better suit different situations or different use cases. Of course, in the case where we have let's say a hybrid solution that we have also highly dynamic pages, but also static pages or server-side rendered pages. That's where it gets more complicated and tricky. So as we can see from this graph, most of the libraries like Style.jsx, Style Components in Motion, TypeStyle, Fella, Stitches, Goober, and Compiled support the runtime style sheets. Static CSS extraction is not that popular. Vanilla Extract, Linaria, and AstroTurf, as far as I know, implement, and Stylex, of course, implement this method. Also, Compiled, which is a library from Atlassian, added experimental support, but it's not released yet. So yeah, I can see that more and more libraries start to tackle this method as well. So you can check out the full analysis at my GitHub page. It covers a lot more information and a lot more topics and features that all these libraries have to offer. So with this, I thank you all, and if I'm open to discussions. If you have any different opinions about the way these things work and the way I presented them, I'll be happy to discuss them. Thank you.
Thank you so much, Andrei. That was a wonderful insight on all CSS in JS libraries.
Thank you. Thank you.
No, okay. Maybe okay, there's one from Naman. Did you come across a library that statically extracts CSS but also implements critical CSS?
I don't think so. I mean, as far as I understand, I don't think that extracting the critical CSS is part of the CSS-in-JS library. I think it has to do something. I think it should be something done at the framework level or at the application level. And I know for a fact that Next.js, I don't know if they shipped this support, but they will be shipping this feature soon. So when performing server-side rendering, to ship the critical CSS as well. So no, to answer your question, no, I don't think so. I don't think so.
I do just want to. Oh, sorry, you go.
Yeah. No, I was
just going to say a couple of things. So vanilla extract on this topic, vanilla extract, we don't talk about it much, but it actually does have a fallback runtime version. It's more there for like testing. So if you run your code in Jest, for example, like the actual like CSS code will execute. But importantly on this question around critical CSS, we don't officially support it yet, but Matt Jones, who's like written the most lines of code in vanilla extract, he's actually literally just in the last week or so got like a prototype of this working with vanilla extract. And this is basically by like, because of the TypeScript code that you write in your style sheets, you effectively just like execute the code in the server rendering environment, and then we have a method of keeping track of which classes actually got referenced in the HTML. You have to analyze the HTML file to see which classes got used, but then we can pull those styles into a style tag at the top of the page. So it's not something we officially support at the moment, but there may be something soon.
But I have a follow-up question here. Like, how does Vanilla.js or the CSS-in-JS library know what is a page in your application?
Yeah, so the trick is you have to feed it a string of HTML. That's the way it works basically, because it keeps it generates all the styles and keeps them in memory, and it says, okay, well, I know all of the CSS that could possibly be referenced, and then you say, well, here's a string of HTML. Give me what I actually used. That's basically the trick.
Okay, got it.
The thing that I prototyped for Stylex is pretty much the same. It's a big map of all the class names, and then you just pick out the ones that you actually used on first render.
Cool.
And also, I would like to make one regarding critical CSS. One thing that for me was really confusing when I first encountered this term critical CSS when talking about CSS-in-JS, is that it doesn't refer to above the fold critical CSS. Like if you search on your favorite search engine critical CSS, you will not get any of the CSS-in-JS critical CSS. You will get a lot of articles about the above the fold critical CSS, which means the CSS required only for the first part, the top part of the document. And these CSS-in-JS libraries do not extract that above the fold critical CSS. That's something that is not trivial to perform, and it's very difficult. So just to keep that in mind, I think it's very important to understand the differences between these terms.
I'm actually unsure how to even do that manually, because how do you decide where the fold begins?
I've never been a believer in that approach personally. Like I've always felt it, the thought of like, what if your connection's a bit slow and you scroll down? What are you even looking at? Is the bottom half of the page broken? It doesn't sound right to me.
Yeah.
Yeah, it's very complex to do that. There are some libraries that use different techniques to extract this, but I don't think it's very safe. And it can guarantee that all the styles required for that above the fold part will actually be extracted properly.
Andrei, I have a quick question. Of all the CSS and JS insights that you showed, what's your favorite one and why? And JS insights that you showed, what's your favorite one and why? Like what you have been using the most?
Again, I try to be unbiased towards these libraries. As mentioned, I use the treat and will migrate to vanilla extract, but only because we had to perform server-side rendering. So this is and we wanted to have a good caching of the resources. We had the solutions basically are not highly dynamic. It's pretty much our use case was pretty much the same use case as Mark's solution that they are working on. So it resembles pretty much the same needs. That's why I choose that particular library. But if I was to work on a single page application, highly dynamic application, that's difficult. I don't know exactly how to answer that question. So it's when you get to specific. It's easier to talk about specific applications, specific use cases than to talk about generic ones. So I cannot say that I have a preference for one or the other.
Okay, so I think we are done. And thank you so much, Andrei, Mark, and Naman, for all your insightful talks that you gave. Thank you so much. And yeah, see you all later in the session. Thank you so much.
Yeah.